Everybody, thanks for coming in. I know you just heard me at the opening remarks, so I apologize, but I just want to do a quick introduction to our speaker. This is Milecia McGregor. I do that right? All right, perfect. Welcome. Milecia is came to us from Tulsa, Oklahoma. So she had a long flight yesterday. She told me she flew from Tulsa to LaGuardia to Richmond. Yeah, what a trooper for coming here. Milecia is a senior staff engineer at Method, where she works with a bunch of clients. She's written a book on O'Reilly. Actually, we talked about that. I mentioned it on LinkedIn. So if you're on LinkedIn, please follow Milecia there. Milecia McGregor, you can find it that way. And it's MC Gregor. So, but she's taught a bunch of courses with Pearson, and then she's also spoken at conferences around the world. And most of the time that I've seen to 5-star ratings, so no pressure. But take it away. You're on. Thanks so much.
All right. Good morning, everybody. Oh, it's weird to be in the classroom again, but you know, we're here. Today I'm going to talk to y'all about preventing these security vulnerabilities that keep popping up. I'm not going to teach you how to make apps bulletproof because that's literally impossible, but we can do the little things a little bit better, every day. So real quick, Galen gave that intro, but want to give you just a little splash more. So my name is Milecia. I am a speaker. Sometimes I write things a lot, like this book with O'Reilly. It took 2 years. It's a great book, but I hate that book because it took 2 years to write. I love all things tech, except for R. R is bad. It's not, but it's a thing. And I'm a pilot, so I fly planes, and I do martial arts, so I'm in spy training right now.
So you fly here from Tulsa?
No, I wish, but that's a little bit too far for me right now, especially in a Cessna. No. Oh gosh, no. But today I'm gonna go through 5 different scenarios with you on just some common things I've seen across a bunch of different projects over the years, and how you can prevent some of the vulnerabilities that come up, and how you can work with other teams and hopefully your team to make things more secure. So the first thing, how many people have implemented a forgot password flow? No, that tracks. It's a pretty common thing because that's like a form of multi-factor authentication, right? You just forget your password and click the button every time you need to log in. So typically, this is like a very, very basic version of a forgot password flow. You have the user put in their name or email or phone number or whatever. You do some kind of validation on that input on both the front end and the back end. Some people will argue to death that you don't need it on the back end, but they're wrong. You do need that validation on the back end. Then once they've issued that, you know that they actually exist in your system. You can move on to sending them like a one-time password. So they'll go to their email or device, which we hope is not compromised. But again, we can't prevent everything. Then we verify that one-time password. So they type in the little form or the modal, and then they get the magic window where they can make a new password. So let's dive a little bit into that. The main thing with the forgot password flow is this risk here, insecure design. So I'm going to go through some of the OWASP top 10 in kind of the same format, but you can have a feature that is just designed in an insecure fashion from the jump. So let's say, let me find the right window. Let's say that you have some kind of board. Pretend this is Jira because I know everybody loves that. So product has written this great ticket with some kind of detail. So we have our basic description, we have the given and when then. Hopefully your product team does that. It makes them more privy to the technical details, and it helps with writing test cases for both unit tests and for a QA team. But that's one of the ways you can start getting the product team involved in this whole security discussion. Have them think about it too. Of course, it comes back to you because you're the technical expert, but everybody should be thinking about security, even the designers. Which brings me to my very poorly drawn Figma design. I'm not a designer. This is a modal flow. So we have an input for the username, button. We have the same thing across the board. Designers will make this much prettier than I ever could, but I just wanted to give you the general idea. So you would get your requirements from this ticket, you would get the designs from the design team, and then you go through grooming. So that's when you start figuring out, okay, what does it actually take to implement this? Product is going to have a few things that, they've thought about from a higher level, but then we get into things like creating endpoints. And this is where you really start to shine. So to break this down a little bit more, you might be like, hey, product person, I need more tickets. Do you want to write them or do you want me to write them? And depending on your product people, it could go either way. My product people, it depends on the day. They might write them, or I might just do it because you know the technical details, you know how long it's going to take, you know what you need to do. And if you don't, writing it down helps you figure it out. So let's start with just some basic stuff you would do to implement these 3 different endpoints. So let's say you have this post OTP endpoint. It's going to take the username and it's going to do these 3 things. So it'll validate and sanitize that data, which means it's checking for the format of that username. Have they put in weird characters? Did they just write a SQL query? What actually went into that form before you submit it to your database, your service, wherever it's going? Then you need to make sure that the user actually exists. And it sounds like a very basic thing, but you'd be surprised when people get in a rush. They're like, they typed something in, just send them an OTP. And then they get stuff that they shouldn't in very creative ways. And errors. There should always be some kind of error handling. That's another thing that I've been surprised over the years is the database might throw something and there's nothing to catch it, and now they have some more info on your database than they should. So error handling is essential, not just on the front end, on the back end too, which it looks like everybody in here knows that already. I'm glad, I'm proud. I love when that happens. So we kind of run through the same thing with the rest of these endpoints as well. You make sure that your input is sanitized and validated. You make sure that your errors are caught. And when you do this verify of the one-time password, that's when you'll return some kind of token the user can use to update their password. And that's where things get a little bit more into the weeds, and we'll get into that. And then on the password itself, as much as it can be annoying as a user, those password requirements are important. How many of y'all have used, I think it's Microsoft SQL Server? So y'all know the 1, 2, 3 QWE exclamation point, exclamation, exclamation. So many people actually leave that on prod, and I'm like, y'all, come on now. This is just out here. But that's why we have password requirements in our systems, in case somebody set things up and they left that password there. So, it's a quick rundown of how you might work with your product team and your designer to actually start thinking about security and putting it more top of mind instead of like, oh crap, somebody DDoSed us. Who escalated their roles? How did they get access to that particular admin account? So this is one of the ways that you start making everybody in your org aware of those different security things you can put in place at the ticket level. And it helps product know why you're taking forever to get through something that's simple. So let's look at a little bit of code around here. So I made a little Next app. It kind of runs, but that's not the point today. Forgot password. So it's a very basic implementation. Can you all see that?
Should be in dark mode, but yeah.
Hey, where you at, Milecia? I'm on your team.
I was wondering if somebody was gonna call me out for that. I can't see. I need light. So this is a very simple next page. And this is how we're implementing the flow on the UI. First off, I would never have this many components on a page, but I don't want to flip between files all the time. So everything is here, but just imagine it's separated with its own state handling and it's beautiful with styles and not just basic HTML.
It's really beautiful.
Thank you. I know you can see. So what we do is just regular stuff. So first, the user puts in their username, and then we call our back endpoint just with fetch. No fancy React query, nothing like that yet. Although that's a good thing to use for performance and caching and all of the cool things that you don't want to write the code for. So let me clean that up. All right, so now we're on our one-time password endpoint. So it's taking in this request, it's going to send a response later. But for now, first check, is this a valid username? So function to check valid username. And you'll notice everything is kind of split apart. So when it's time to write those unit tests we all love to write, you can do it a lot easier instead of having to nitpick through error messages that actually don't make sense to the error. But hey, what do I know about v-test? But anyways, we have this regex is just checking that it has like characters we expect. You notice there's no special characters except maybe the underscore there. But it's a way to keep people from just injecting whatever they want into an input and sending it to us. And if this returns and it's not valid, then we actually update their attempt count. So something that a lot of systems do now is they give you so many tries before they just lock you out. And they're like, try again tomorrow, few hours, call somebody, whatever it is. So don't just let people keep spamming input. So we update that count every time there's a failure. And then in this case, we send a 400 because they don't exist or the username is invalid. So don't be afraid to use specific error codes. I know some people are kind of like on the fence with that. They're like, oh, it gives attackers more information. It's a choice, it's a preference, but the difference between a 400 and a 404 isn't gonna give them a whole lot to go off of. But it will help you debug things, and it'll help the front end make better error handling. So after we check the username is valid, we see if it exists, and in separate function somewhere up here. So if it exists, then we continue through the flow. So let's see. Then we get to the end. So valid, they exist. Then we check the number of attempts, which is something that they cannot change externally. So we actually have a record of the number of attempts in the database associated with that user that gets updated every time they try to send a request. And it will get reset when they make a successful request or after a certain amount of time, or they call customer support. So after all of that, we finally send this one-time password email. So that might be something with NodeMailer or SendGrid or whatever email service you use. And then we send the 204 back to the front end, which then shows them the one-time password input. Again, beautiful, looks just like the Figma design I showed you. So after they get that email, they come in here, type in the number to the modal, and we go back to the back end. So now we're verifying it. And basically a couple of things happen. So first, the OTP should be a number. If they try to type in a string, hopefully the front end, not hopefully, the front end will not let them because we can use text inputs instead of just, number inputs instead of text inputs. So be specific in your code. These little bitty things actually matter. So when you're in a rush and you're like, just slap an input on it, think about what type, because that's a first line of defense to prevent these attackers. Then this is my fake database. So it'll come in here and check to see if the current OTP matches the one that they entered. And if it doesn't, we tick that attempt count up again, return our 400 status, and go through the process again. Then you'll see if they hit 5 attempts, we just block them out. So that's the gist of what we keep doing throughout this flow. We check everything, kick them out if it's wrong, update their count. So those are some of the little things that don't take a lot of time to implement that you can do every day. So be mindful of that. And then something else that really, really helps is when you write out the test cases that you need in order to include your security concerns. So let's say you're looking at this username model. Think about all of the scenarios that somebody might try and write a test for it. Even if you don't write a test for it and you just kind of spec it out like this, it'll help you think through the code a little bit more thoroughly instead of just, oh, it works. It's fine. It passed QA. But there's certain things QA is not going to check for. They're not going to try to probably do some kind of SQL injection or, try to send values that are too outside of the box. And that's, again, where you come in as our first line of defense. So these are just some of the things when you're implementing common flows like this you should consider. All right, so I'm gonna come back here. And I think I just talked through all of my potential preventions. So that's fine. That means we can get to the next scenario. Requesting data from endpoints. Is everybody a full stack developer in here? No? Got some UI specific, backend specific folks. Alright, that's fine. But regardless of where you sit on the stack, it helps to understand what's going on in the part that you don't work with every day. So this is just some fake endpoint. And there's a few different things that I'm highlighting here. If you've worked with a company or even a third-party service that versions their APIs, take note of that because it's kind of important later. And then, of course, we pass in different parameters. Maybe you have a query string with some data in it, and you have probably some kind of body associated with it, or form data, or something that you pass to this endpoint. the thing here is that there's a lot of times these endpoints have broken access control because somebody is like, oh, well, if they're calling this endpoint, clearly they've already gone through the authentication flow. They've been authorized, so I don't need to check that anymore. Yeah, you do, because somebody might just take the endpoints and use something like Postman. They might use curl commands and completely go around all of the flow you have set up in the UI. So don't ever forget that or underestimate it because people will do it. I know personally I've done it just for fun. I'm like, what are y'all doing back here? How much can I get from this endpoint? And say, oh, crap. I don't know if this is legal. I should probably get out of here. So, broken access control is huge, literally the #1 problem. And then, of course, injection. So if you look at this endpoint, it's like you see these little values in here, and you can go, I wonder what that's for. And if there's good API documentation, you can find out exactly what that's for. So that's when you can start picking at it like, I wonder if I type this in, will this work? What will this give me? What if I type in an order ID that I don't have? So things like that give attackers different vectors to try out. And that's why when we get into our actual design, I think I'll show some code real quick. So
Sorry, Milecia, what was the loss for the SQL injection? What was the number for that? I'm just tracking it. Loss 3, thank you.
no problem. Okay. How many people are familiar with serverless functions? Yes. It's the new shiny thing. Can't wait to see what replaces it in 6 months. So let's say we have this AWS Lambda function we're working with. You can just straight up use the event path parameters. You can get the body. You can do all of the things without a whole lot of authorization around it. So maybe you have some kind of auth on the gateway, but nothing really on the, oh no, don't go off. Why would it do that?
Nope, it's back.
Okay. So don't do this right now. But maybe you have stuff on your gateway, maybe you don't. It depends on who set it up and how they felt that day. So that's where you come in and actually make maybe your own kind of authorizer. So something that I've seen work really well, ignore the fact that this is a JS file for a second. But if you make your own class for an authorizer that has all of the logic in it, then you can create new instances on each endpoint to pass in whatever specific like roles and permissions a user might need, what types of services the endpoint can access. So down here, this is something that sometimes it gets left out. You have a JWT that gets sent back, but do you actually use it the right way? Are you checking that the data that's returned in this endpoint is specific to the access level that the user has? Because sometimes maybe, DevOps, anybody else creates these users and they just give them blanket permissions and they have access to everything, even though they should only have access to like one thing. So check your tokens and make sure that you have your endpoint scoped to a specific set of permissions. And I'm actually going to show a fun little thing with the last scenario in here, but for now, authorized endpoints, please don't leave that up to the front end. And also, when you're thinking about how you want to handle these different serverless functions, even if you're working in a monolith, make sure you separate logic out So everything should not be in your handler file. That's bad for a lot of different reasons. But the main one is that it makes it harder to debug whenever you encounter some kind of issue or vulnerability. It also makes it harder to track things on prod when you do run into some kind of attack. So make sure you have things separated out, kind of like we do here. So database calls go in the service. Business logic, probably in the service. If there's anything you can catch, like, let's say they put in a bad format for a user ID or something, then you could use a tool like MIDI to start stacking different middleware to check these different, what's the word? These different cases. And of course, error handling. Always have that. Don't just let the database errors pass through. Don't let your business logic seep out. Catch it before you send it. That is one of the best cases of prevention you can have. Then something else. Define your roles, please. You can have them in a central location. You can share them across repos, whatever it is. Just make sure everybody understands what roles different endpoints should have, what users should have those roles, and where you get them from. So this is just an example of something that I've seen implemented over the years that works pretty well. It's easy to read, it's easy to go through whenever logs come in and you're like, oh, I wonder why they don't have permission for that. Oh, because they don't have the role for that. So make sure you have those kinds of little things in place. Always the details. And so back to just a checklist. That's what these prevention slides are for. It's just a little checklist for you to go through as you implement different code. So sanitize all of your values. Just do it. It's like washing your hands, but with code. Then have your access level checks on all of the requests. Don't forget that anything you send over an endpoint is publicly accessible. Anybody that calls it can see whatever that payload is. They can see what was sent in the request, and they can see other things like maybe special headers you have that will tell them what services you're using. So be mindful of every little thing you send on those endpoints. And lean on your team. Sometimes it's hard to remember all of those little things. Start a document that you update as you find those things to add to your security checklist. Log and monitor things. Failures are important to know about because they can be the indication of when people were trying to do something wonky with your system. They help when you're looking at those, attacks that happen at 2 a.m. and you're on call and nobody else is around except your logs. So that's why it's important to use those specific status codes. Send error messages in the logs that give you maybe a little more detail than what you would send in your response. That'll help you get to the source of it a lot faster. And don't directly interface with the database in requests. That's bad. Please don't do that. And as always, if you have an endpoint that returns a bunch of data, maybe paginate it, Don't return it all in one lump. Your UI will thank you a lot that it's not in the loading state for like 12 seconds. And you don't want to give all of the data away in one request.
Milecia, can you define don't directly interface a little bit more?
Yeah, so basically, when you are writing the code for your handler, like here, don't put the database stuff in there. So there should be no DynamoDB things, no Postgres, no whatever the other database products are right now. Don't put those in here. Keep those separated out into a different service layer. because that helps you when errors come up, it's easier to track them down. You can be more specific with how you define business logic, where you pull in environment variables from. It's more of a separations of concerns type thing.
Okay.
And let's go to the next one. So I'm not going to call these legacy code bases because I don't know. Legacy is 6 months into a project. But let's say you have just a bunch of different dependencies. And I highlighted a few. You notice how this is still on React 16? It's a little problematic. You know, we're using an outdated version of an encryption package. Might be a little bit of problem. So I want to ask, how many of y'all have run npm audit recently? Oh my gosh, y'all are the
I
best.
live in that world.
Most people are like, I've heard of it.
Now, do I do anything about it? Yeah, if we did that, we'd have to do something about it.
Exactly, that's why you make a ticket. Give it to product and make it their problem. Hey, we need this. But you don't want to see 66 vulnerabilities, especially in things like maybe Node Miller, it might have some stuff. Maybe body parts. Express probably should be up to date. You know, there's a few things in here that should probably update. And you can try to do that with npm update and see how much stuff it breaks because your dependencies don't work together anymore. And now you're in a dependency nightmare of trying to find the right versions of everything to work with everything because somebody left you on React 16 and now we're on 19. It's fine. It's so fine. I'm not mad at all. But if you do these kinds of checks, like every quarter or so, you don't fall as far behind. Now there's 44 instead of 66. I wonder if this app will still run. Probably not, but I digress. So there's stuff like that, because this goes straight into some more of the OWASP top 10. So cryptographic failures, you know, you're running old versions of cryptographic packages. You know, we used to use MD5 a lot for password hashing. Yeah, don't, it's bad now. It has, what is it, the issue with collisions where two inputs can produce the same hash. So if anybody's attacking your app and they have that kind of patience, they can eventually forge a hash that works, which is unfortunate. And it's a pretty fast algorithm, so brutal attacks, brute force, brutal attacks, you know, they are brutal. But brute force attacks can work on the MD5 algorithm. So use something like SAH256 or AES for your passwords now. Then I know y'all have seen how many npm packages have just been like maliciously updated. So you don't want your code to depend on something that's literally opening an attack vector to your app. So maybe look at what the most recent versions are. Do a quick Google search. I don't know. Google's pretty bad these days. But try it anyways. See what comes up. Maybe check out ChatGPT, which I cringe a little bit to suggest, but we're here. So those are some of the potential risks. And for your prevention checklist, just use the latest stuff. Hopefully it's been patched correctly and hasn't introduced any malicious code. Remove those unnecessary dependencies. It'll help with your bundles a lot. And verify your configs, because sometimes those get set, you know, at the beginning of a project 10 years ago, and nobody touches it because nobody knows what it does. So nobody knows what it does. Be the hero. and find out. Then this one comes up a lot when you're working with serverless functions. You need to make a new backend project based on an existing template. So copy paste to anyone. If you have some security configs in there that aren't necessary for your new Lambda, well, now it's there and somebody can probably figure out a way to take advantage of it. So go through and check things like your serverless files. So do you have the databases that you actually need to be connected to? And just those, not all of them, just the ones for that specific Lambda. Do you have the right properties defined? Do you need write capacity, or is this just a Lambda that's going to read data? So again, the little things like that make a big difference with your security vulnerability. So go through before you copy paste, at least check the YAML file and make sure you don't give more access than you need to. And get rid of the boilerplate. You probably don't need it. If you do, it'll find a way to etch itself out of all of the muck, and then you can keep it in the template instead of just having it there and nobody's using it, because an attacker with enough time and patience and grit will probably find a way to use it. Check your cloud configs, because again, sometimes maybe the DevOps team is just like, we'll provision it the same as the other. Does it need to be the same as the other? Maybe, maybe not. But go through and kind of check it with them. And if you can, try to use the same environment configs with different credentials. So that will help you keep a certain level of consistency across your apps without the risk of maybe using the wrong credentials in the wrong place. So keep that in mind. And then the last thing, this is my favorite. Copy paste. We all do it. We all do it at some point. But do you actually know what that code means? So you've been looking for something on Stack Overflow for 3 days, and you finally find something that works, and you're so glad to be done with that ticket, and it's forget it, it's done. Here's a couple unit tests, quit. But you don't actually know what that code does. That's a problem. Same with ChatGPT, Copilot, Cursor, whatever your AI thing is. It doesn't know more than you. I promise you it doesn't. So something that actually happened earlier this year, one of the people that I'm mentoring was like, hey, write just a role-based access control thing for me. Keep it simple, keep it light. And they used this. And I know because I typed in the same thing to figure out what they were doing. I'm like, wow, this is really well commented. Oh, you've been programming for 2 years and you already got this? Wow, I'm a little slow then. Then it's oh, explain what this is to me, please. And then they started fumbling through it. And it's okay. Please don't copy and paste from the internet. That's always been bad, but the problem with using tools like ChatGPT or something else is that a bunch of other people are doing the same thing, and they're putting it in their code without really understanding it or validating it. And so your friendly attackers come through and write the same thing in the ChatGPT, and they're like, what are the holes in this that I can poke? What are the vulnerabilities? This is starting to become a much bigger attack vector than I think is being talked about, because a lot of people are just copy and pasting this and it pretty much spits out the same code every time. attackers are just gonna start using ChatGPT to figure out what code we're writing, and then they're gonna write their stuff to attack what the bot wrote. So it's basically gonna be like a bot fight that's facilitated through us.
Easy answer. Ask ChatGPT to make it completely secure.
That's the part we're missing in the prompt.
Yeah.
You can go home early.
That's exactly the answer. Just ask ChatGPT to make it secure. But yeah, don't copy paste without understanding what it does. So this is all of the risks. So anything you find in the OWASP top 10, if you're copy and pasting stuff from ChatGPT or Copilot or whatever, pretty sure it touches on at least one of them, if not multiple. So be wary of our new AI overlords, please. They're doing their best, but people still exist that are smarter than the bots. Don't just copy paste code without understanding it. Please read the code and understand it before you use it. So, that's it. Got some takeaways for you. Do an OWASP top 10 every now and then. Just check to see if your app doesn't have those vulnerabilities. And if it does, work with product to write some tickets for it so you can actually get to work on it without being like, oh yeah, I spent an extra 10 hours this week on stuff that's not on the sprint, and I'm behind on 2 tickets, but this was really important. Make them make it important. That's gonna help you, and it'll give you more credibility when you ask for tech-related tickets. Do some kind of quarterly security check. That whole NPM audit thing, it helps a lot. So you don't fall like 4 major versions behind the package and end up in dependency hell. Like, just don't. And don't copy and paste code without knowing how it works. Understand it before you use it, or use it and then understand it, but don't put up that PR until you can explain what it does. So that's it. Hopefully this was useful and you learned something, maybe a little entertained mildly this morning. So y'all got any questions? Yes.
What is your, for the critical or high vulnerabilities, like, is there a recommended timeline for remediation? I mean, obviously immediate would be nice, but like I've seen some places that have a staggered time frame where critical has to be done within a week or something, and high. Like, do you have a recommendation, or are those just arbitrary? Like, why do they pick those times?
It kind of depends on the company, because I know more finance companies, if a critical vulnerability opens up, they want that within like a week, maybe a month tops, depending on how bad it is. But it varies by organization.
So I resonated with your like last slide of like potential risks, all of them, and like being on a small team, you know, it's pretty overwhelming to like get your feature development through and all this stuff too. So I usually lean on like static code analysis to like try to bubble some of this stuff up. Do you have any recommendations or positive experiences with any tools like that are kind of like scanning your code base and trying to like get this stuff in front of you in a digestible report beyond NPM audit?
I like Sneak.
Sneak?
Yeah, SNYK. I like that one a lot. And I think Veracode is a pretty good one, because they do some, what is it, DAST? They have some kind of DAST tool too.
Yeah.
No, there was another one, but those are like my top 2.
Cool, thank you.
So I have a question about regular expressions. So how would you solve weird security vulnerabilities included in regex is the regex is vulnerable because you can repeat multiple times a certain character or something like that.
Yeah, regex. So personally, the only way that I've seen to do that is to test out the regex you're writing a bunch of times. It's not a fun method, but you might be able to write some kind of test that passes in a bunch of different values to the regex and then tweak it as you get results back. But that's kind of the main way I've seen it implemented for regexes.
Okay.
Like brute force your own regex.
Pretty much. Regexes are hard, man. I hate regex. Yes.
Do you encounter a lot of, I remember with JWTs back in the day, it was like people got encoding versus encryption wrong. And like, is that still a concern where people are just like, yeah, I've got JWT, it's fine. And would you like, is there any recommendation of, I remember just like encrypting the body or whatever of that, but I don't know, has it advanced since, I don't know, 5 years ago or?
It's about as advanced as the person or the team implementing it. So one of the best JWTs I've seen is where they encrypt every value in the token. But I'm not sure if it gets a whole lot more sophisticated than that.
Okay.
Anybody else?
Well, I have a bit of a clarification.
Yes.
You mentioned Sneak and Veracode.
Mhm.
Are those warehoused or pigeonholed specifically to JavaScript code base, or do they work on a broader context?
That's a good question. I haven't used them.
Veracode is definitely broader.
Okay.
Okay. Well, I haven't used them on anything with JavaScript code bases.
My role uses JavaScript sometimes moderately, but our normal code base is .NET, so it's trying to figure that out.
Well, maybe check out Veracode.
Sonar Cube too. Is
That's
really
the
good.
one. Yeah, Sonar Key.
Sonar Cube.
With it,
Q.
Yeah.
QUBE.
Friends with Mike, he's mentioned Sonar.
Yes.
How do you solve the constant debate of where to store your JWT? And local storage versus a cookie. Some have this, some OAuth vulnerabilities, other options do. So how do you solve that when developers have opinions?
I mean, technically, the most secure route would be in session storage because it'll just get deleted and the user has to off themselves again every time they leave the page. Well, that's a terrible user experience. So the thing that I've seen is just make the token expire after a certain amount of time. But local storage versus a cookie, either one is fine as long as that token expires eventually. Anything else before I get kicked out of here?
Could you remind us of your O'Reilly book again?
Oh, yeah. That's the picture of the book. It's like 400 something pages. Whew. Again, I love that the book is done, but I hate it.
Okay, I have a question for this entire group. Is anyone here a VC alum? I know I am.
Yeah.
Thanks.
All right, thanks, y'all.